What's up guys, and welcome back to my channel. Now in this video, we'll go ahead and focus on simplifying logarithmic expressions and trigonometric expressions using logarithmic and trigonometric properties. So let's go ahead and jump right in. Now for this first example, go ahead and consider the following expression. F of x is equal to the log of x plus 1 minus 5 times the log of 2 minus x plus the log of 3. Now, what we want to go ahead and achieve is simplify this expression to only one term. And so before we actually go ahead and jump into that, let's go ahead and write out the logarithmic properties that might be useful in simplifying this expression down. So the first property says the log of x times y is equal to the log of x plus the log of y. The second property that we'll go ahead and use is the log of x divided by y is equal to the log of x minus the log of y. And the third property we'll go ahead and use is the log of x to some m power is equal to m times the log of x. And so using these properties, let's go ahead and try and simplify the expression that we have. All right, so we're going to go ahead and start off with property number 3. And we're going to use property number 3 to go ahead and simplify 5 times the log of 2 minus x. And using the exponential property, we can go ahead and rewrite this as the log of 2 minus x raised to the 5th power. Now let's go ahead and use property 2 to go ahead and simplify the log of x plus 1 minus the log of 2 minus x raised to the 5th power. And so these two terms can be simplified to the log of x plus 1 divided by 2 minus x raised to the 5th power. And finally, by using property 1, we're going to have the log of x plus 1 divided by 2 minus x raised to the 5th power plus the log of 3, which is equal to the log of x plus 1 divided by 2 minus x raised to the 5th power times 3. And so the expression that we were given was log of x plus 1 minus 5 times the log of 2 minus x plus log of 3. And so by writing down these logarithmic properties, we were able to simplify this expanded expression of logarithms to the log of x plus 1 divided by 2 minus x raised to the 5th power times 3. Alright, so jumping into the second example, we have a function defined to be g of x is equal to the secant of x minus cosine of x. And according to the problem, we want to go ahead and simplify g of x as much as we can by only using tangent and sine of x. So let's go ahead and write the first trig identity that we can go ahead and use to go ahead and simplify this problem down. Now, from your trig identities, you know that secant of x is just a reciprocal of cosine. Or in other words, secant of x is equal to 1 divided by cosine of x. And so by using this identity, you can go ahead and write g of x is equal to 1 over cosine of x minus cosine of x. Now, at this point, you have two terms subtracting from each other. The first term is a fraction, and the second term is just cosine of x. Now, since we're dealing with fractions, let's go ahead and change cosine of x to have the same base as the first term, so we can go ahead and combine them. So we'll go ahead and take cosine of x, and cosine of x can be represented as a fraction by writing cosine of x divided by 1. And if you go ahead and multiply by cosine of x in both numerator and denominator, then in the numerator, you'll have cosine of x times cosine of x, which is cosine squared x. And in the denominator, you'll have 1 times cosine of x, which is cosine of x. And so notice by doing this, we were able to convert cosine of x into a fraction that can be combined with the first term. And so we can go ahead and write g of x is equal to 1 minus cosine of x, which was the first term, minus cosine squared of x over cosine of x. And by combining this fraction, we'll go ahead and keep the same base, which is cosine of x. And we'll just go ahead and combine the numerator, which is 1 minus cosine squared x. To go ahead and move on, we're going to need a trig identity to continue simplifying this expression that we have. And the trig identity that we'll go ahead and use this time is cosine squared x plus sine squared x is equal to 1. But notice from the numerator that we don't have cosine squared x plus sine squared x. We have 1 minus cosine squared x. And so somehow we're going to have to manipulate this identity that we have right here to fit the pattern that the numerator exhibits. And so by subtracting cosine squared x from both sides, you'll get the following equation. Sine squared x is equal to 1 minus cosine squared x. And so now that we have the pattern that the numerator follows, we can go ahead and write the following. G of x is equal to 1 minus cosine squared x over cosine of x. Now, with this trig identity, we can go ahead and substitute 1 minus cosine squared x with sine squared x. And by doing that, we'll get sine squared x divided by cosine of x. And through algebra, you know that sine squared x is just sine of x times sine of x. And we can go ahead and decompose this fraction and write g of x is equal to sine of x divided by cosine of x times sine of x. And so we're almost at that point where we have g of x simplified down to tangent of x and sine of x. All we have to do is take care of sine of x over cosine of x. And so let's go ahead and use our last identity, which says that sine of x divided by cosine of x is equal to tangent of x. And so taking our g of x expression, which is sine of x divided by cosine of x, times sine of x, we can go ahead and simplify the fraction sine of x divided by cosine of x. And we can go ahead and write g of x is equal to tangent of x times sine of x. Our final answer. Alright, so if you guys have any questions, go ahead and drop those questions down in the comments, and I'll go ahead and see you next time.